All right, today we're jumping into a really fascinating story out of southern Thailand. It's all about how a totally new way of looking at data is helping officials fight a trio of deadly enemies, all carried by mosquitoes. It's an amazing case study in how just asking a different kind of question can literally save lives.
So here's what we're going to cover. First, we'll look at the sheer complexity of the problem on the ground. Then, we'll get into the really clever new method these researchers used. After that, we'll see what this method uncovered about 3 very different diseases. And finally, how all of that new knowledge gets turned into a much smarter defense.
Okay, let's dive right in. We're starting our story in the southernmost provinces of Thailand. Now, this is a region that has been fighting a really tough, persistent battle against mosquito-borne diseases for a very long time.
And this is the core of the problem. It's the central question for every public health official there. When you've got limited money, limited staff, how do you fight 3 different diseases that are all happening in the same place at the same time? It's a massive puzzle, and every choice matters.
All right, so let's meet our 3 culprits. You've got malaria, which is a parasite that really loves those deep, rural, forested areas. Then there's dengue, a virus that just spreads like wildfire in both cities and the countryside. And finally, chikungunya, another virus, this one famous for causing just awful, debilitating joint pain. The thing is, each one acts differently, so a one-size-fits-all strategy just doesn't work.
So, how in the world do you start to make sense of all this patient data? Especially when a ton of villages report 0 cases. It can make it seem like the diseases aren't a big deal. Well, the answer comes from a really clever shift in thinking. You split the problem into 2 separate, very specific questions.
And this is such a critical point. See, the old way of doing things, like just averaging the disease rates, can be super misleading. All of those communities with 0 cases end up watering down the data. They can completely hide the true hotspots where the disease is actually raging. It's a huge statistical challenge.
So, the first question they ask is super simple. Occurrence. It's just a yes or no. Is the disease here? Yes? Okay, put a pin on the map. We're not even counting how many cases there are yet. We're just finding every single place the enemy has shown its face. That's step 1.
Then comes the second question, intensity. Now, only for those places we just put a pin in, we zoom in and ask, okay, how bad is it here? This is where we measure the severity, the number of cases per 1,000 people. And this gives us a totally different, much sharper view of what's going on.
So you can see how this works, right? It's a 2-step process. First, you model the occurrence to find out where the problem is. Then you model the intensity to figure out how bad it is in those specific places. Separating those 2 things is the secret sauce.
All right, let's put this method to the test. We're going to start with our first investigation, decoding the true profile of malaria, a disease that has haunted this region for generations.
Now, if you just looked at the raw numbers, you might think malaria is kind of rare. It only showed up in just under 10% of communities over a 12-year period. But, and this is a huge but, that number is actually hiding a much, much more dangerous story.
And this is where the new method just blows the whole thing wide open. You get this incredible split. The occurrence, just getting infected, is highest in young adults, people in their 20s who are working outside. But the intensity, the most severe cases, that's highest among the elderly, people over 60. Think about that. The people getting sick the most often are not the ones getting the sickest.
And the analysis gets even more specific. It pinpoints the geographic hotspots with stunning precision. The highest risk areas for both getting malaria and for getting it severely are all clustered in the mountainous forested areas of Yala province right up against the Malaysian border.
Okay, so that's malaria. But what's really wild is what happens when we apply this same thinking to our other 2 diseases. We start to see that each one has its own unique, predictable rhythm. Let's look at dengue and chikungunya. It turns out dengue fever runs like clockwork. The data clearly shows these huge epidemic peaks every 3 years, 2010, 2013, 2016. This predictable pattern is a huge advantage. It means health officials can actually get ready for the big outbreaks before they happen.
And hey, just like with malaria, we see this paradox.
The highest occurrence of dengue is in teenagers, from 10 to 19. They're the ones getting it most often. But the highest intensity, the most severe and dangerous cases are in the very young and the very old. Again, knowing that difference is absolutely vital.
Chikungunya is a whole different beast. It moves to a much longer, slower beat. The entire story of this disease in the region is defined by two massive outbreaks. One from 2008 to 2010, and then, almost exactly 10 years later, another huge one from 2018 to 2020. This points to a decade-long cycle.
And here's maybe the most fascinating part. The disease moved. That first outbreak was concentrated in a province called Narathiwat. A decade later, the hotspot had completely jumped over to the neighboring province of Patani. That kind of geographic shift is a massive clue for figuring out where it might pop up next.
Okay, so we have all this incredible data, all these new insights, but what do you do with it? How does this actually help people? This is where everything we've talked about becomes a real life-saving tool.
Well, this is where it all comes together. Instead of a broad, scattershot approach, you can get laser-focused. For malaria, you target prevention efforts on those young guys working in the forest, but you tell the hospitals to be ready for severe cases in the elderly. For dengue, you prepare for that 3-year cycle, protecting teens from getting it and the young and old from getting it badly. For chikungunya, you plan for the 10-year cycle and keep an eye on where it might jump next. It's a precise, strategic defense.
And we are not talking about vague ideas here. Look at this number. The model can pinpoint high-risk malaria subdistricts with over 86% accuracy. That's a game changer. When your resources are tight, you can send them exactly where they will do the most good. This is what data-driven public health looks like.
And in the end, that's what this is all about. It's about empowering the people on the ground. As the researchers themselves said, the goal is to help decision makers better prepare for and respond to the future. It's about giving them the clear, actionable intel they need to protect their communities.
And that really leaves us with a powerful final thought. This whole story, it's not just about mosquitoes in Thailand. It's a perfect example of how finding a new way to see a problem, in this case just separating where from how bad, can unlock the answers we've been searching for all along.